For this video, we're going to cover poured and block concrete construction. This is also covered in your architectural textbook on pages 979 to 988. Now, if you're going to be answering these questions within the notes, I'd like you to put your name right here in the subtitle of the document, okay? So, first, let's talk about concrete block. It's primarily used for wall systems. It's very rare to find concrete blocks used for floor systems or roof systems because just by their construction, they wouldn't be that strong. They're held together by mortar, which is kind of like a concrete glue. So to use them in a floor, the mortar will just break apart from the shear load. So they're primarily used in walls because they're usually only in compression with a little bit of tension, which to deal with those tension forces, of course, they're going to be reinforced with steel. So we do not want concrete blocks in floor or roof systems or structural systems. We want them in the walls. That's it. Now, a big advantage of concrete block construction is anybody could do it. It's very easy. All you need is the concrete blocks and the mortar, which, like I said previously, is like the concrete glue. You take your blocks to the construction site, you lay the blocks up on a poured in place foundation system, and then eventually you'll have walls for your building. Now, block concrete construction, it takes advantage of a modular design of the concrete blocks. Most block sizes are 8 by 8 by 16. Now, with this, we can use the same block to make any type of length or height of wall or wall opening. But the kickback is that we want to design our building walls to have an even length or an even height. For example, the length of most concrete blocks are 16 inches. So we would want the length of our wall to be evenly divisible by 16. For example, if I have a 32 feet 6 inch wall length, that's 390 inches total. That's not evenly divisible by 16. So I would want to round it down to 32 feet or 384 inches so that I could do 384 divided by 16. That's going to give me an even number of 24. So I know the length of my wall is going to be 24 blocks long. By having an even number, it allows me to not have to cut a block unit, because that will drastically increase the amount of construction time and therefore the amount of money. One big advantage of block concrete construction is that it's cheap if the building is designed right. So now I want you to stop and consider this question to answer. Would a wall height of 10 feet be ideal for concrete block construction? Now moving on to concrete block reinforcement, it's very similar to the reinforcement that's used in all concrete systems. You pump the concrete blocks full of rebar so that when tension forces act on the concrete blocks, they're not going to break apart. We want our wall systems to still be strong because the tension forces will come either from wind or loading from the building. So we reinforce our wall system with rebar. The rebar would go inside the openings of the concrete blocks, and oftentimes there's also an opening through the side so that you can put rebar through the side as well. Whenever your concrete block wall has to support a structural beam, it's good to have a pilaster in the concrete wall system. A pilaster is pretty much a bigger concrete block unit that will fit a lot more reinforcement. If our wall is going to be load bearing for structural beams, then we need to have it be a lot stronger. We can get it a lot stronger by putting bigger concrete units called pilasters throughout the wall system, then also stuffing those pilasters with tons of steel reinforcement, so it's plenty of strong. It's going to help to hold the wall system together under the heavier load when being used for structural purposes. Now I want to pause so that you can consider a question to answer in your notes. Why do you think pilasters have to be used in load-bearing concrete block walls? I'll give you a hint. I've just explained this, but I want you to put it in your own words. Now moving on to poured concrete. Poured concrete, it's when we're not using a standard modular unit. We have to cast our concrete to the shape that we want. Most common with concrete is the use of Portland cement. They pretty much hold the monopoly on cement. Cement is the binding substance that holds the sand and gravel all together with the concrete. It holds it all together. It helps it maintain its shape, which it's composed of limestone, rock, oyster shells, a whole bunch of stuff. Poured concrete, it's just like doing a casting. We have a mold, and then we're going to pour concrete into the mold. It's going to be liquid at first, and then it'll take a couple of days for the concrete to set. So there's three main types of poured concrete. There's cast in place concrete, precast concrete, and tilt up concrete construction. The cast in place concrete, it's the more traditional type of concrete construction. It can take any shape or form. Here, the concrete mold is made and constructed at the job site, and the concrete is poured at the job site. What's common for cast in place concrete is the creation of walls, foundations, floors, roof systems, and beams, but it's most common for making the foundation systems of a building, the floor systems, and the roof systems due to their ease of casting and the limited amount of framing that's needed for producing the mold for those types of systems. To focus on floor systems for a bit, there's two types. Ribbed floor system, which incorporates a metal decking, which would be right on the bottom of the concrete floor shape to provide a good structure and strength for the concrete floor, and to increase the section modulus of the concrete floor. As we've learned previously, section modulus increases the bending strength considerably for any type of cross section. So we would have the metal decking on the bottom, and then concrete would just be poured on top of the metal decking, and then the top would be smoothed out with a sort of blade type thing to make the floor smooth, because we want our floors to be smooth. This is primarily used for office buildings. The other type is the waffle floor system. It's a little more extreme in its increase of section modulus. It's popular for parking garages. You can see that instead of just having a constant cross section that is ribbed, the waffle floor system, there is no constant cross section, but there is a ribbing all throughout the floor system to optimize the section modulus and to create sort of a frame for the floor, which is going to increase the strength. Now, precast concrete. Precast concrete, it's cast at a separate manufacturing site and then shipped to the building site. This is very ideal for beams and columns, but can also be used for walls and floors and roof systems. The big advantage with precast concrete is you can pre-stress it. You can pre-stress the reinforced steel that's going to be used in the precast concrete. You put tension on the steel reinforcement. You pour the concrete in, and then when the concrete has cured, when the concrete is set, you let the tension go on the reinforcing steel, and then that puts the concrete in compression. And as we know, concrete works best in compression. So we're going to have less deflection of our structural members, and we're going to have less likelihood of failure of our concrete members. So that's the big advantage of precast concrete, and it works very well for beams and columns. They can just be shipped to the building site and assembled right then and there. Tilt-up construction is very ideal for wall systems, especially when those walls have logos or grooves in them. Tilt-up construction, it's taking the construction field by storm, because you can have buildings erected in a much faster time frame than with the traditional cast-in-place construction methods. Tilt-up construction, it brings all of the concrete molds down to the floor. So the mold construction process is so much more simpler. The reinforcement placement process is so much more simpler. You just put it all on the floor in the way that you want it, and then you pour the concrete, and then you bring in cranes to raise up the concrete walls when they are cured, when the concrete has set. This simplifies the whole process so that things can go much faster, and it allows you to get things like logos and grooves and things like that, more intricate designs of your wall systems. For our final question, I would like you to consider this: would cast-in-place concrete be best for wall, floor, or beam construction? What about precast concrete? Would it be best for wall, floor, or beam construction? Tilt-up concrete, would it be best for wall, floor, or beam construction? I've said the answers to these questions in the video. You just have to remember it. And finally, to end things here, I want to give you some informative videos. If you follow these links, you're going to have some informative videos showing you the process of all of the construction methods that I've discussed here in this video surrounding the topics of poured and block concrete construction. Look at these at your leisure. Each of them is about 2 to 3 minutes long. I think you'll enjoy them and get a much greater picture of what these concrete construction methods actually entail. So, with that, I will see you with our next activity.